Hi, everyone, and welcome to the Aeronautical Data Systems online training program using the X-Plane platform. Today's flight will include three phases. First phase will offer recurrent training on a normal flight from Newark, New Jersey to San Juan, Puerto Rico. Normal and emergency procedures will be discussed. Next, we'll be demonstrating new iPad over water technology developed by ADS called Ergo360 and show you how it's to be used under normal and emergency conditions. For those of you unfamiliar with Ergo360, it analyzes fuel in pounds and oxygen in psi and converts these energy resources into distance to fly on a geospatial iPad mapping program, thus simplifying a very complex, complicated tabular situation into a visual solution. Ergo360 also displays AIS data, ship location, on the same geospatial mapping platform, and we'll show you how to incorporate this information into the aircraft FMS system. Once ship location can be transferred into the aircraft database, this will allow aircraft automation to fly an instrument approach to a water landing should a ditch become your only option. This procedure will significantly increase situational awareness during a very critical emergency, while at the same time decrease time of rescue and pilot task saturation. This technology expands the safety envelope for any overwater flight, since currently the only ditching procedures available are based on day VFR flight. Using Ergo360 allows for ditching at night or during low ceilings or low visibility conditions without ever visually acquiring the ship. The last part of this training exercise will focus, for the first time ever, flight after an engine failure, followed by a decompression to a successful landing of your choosing. Once the aircraft is stabilized and put on autopilot, it'll be up to you and your team to use whatever tools are available to get the aircraft back on the ground safely. The flight will be in real time and your choices will be implemented in real time. The importance of this training will be to safely conclude the flight after an emergency. This exercise is intended to create a discussion concerning standardization and to identify hazards not commonly addressed and how best to mitigate those risks on future overwater flights using SMS protocols. There will obviously be differences in the aircraft, and my co-pilot and I will follow your commands. We will be your pilots. We'll fly the aircraft. We'll also inform you with status reports on our progress. We hope you'll consider using ADS technology. It's not necessary. The choice will be yours. Just a brief moment to show you the X-Plane platform. This is really a very accurate and precise platform that we've chosen, and it allows us a tremendous amount of flexibility, and it'll give you a good feeling of where you are in time and space. So let's get started. Everyone should have a flight plan they can review. The aircraft is positioned for takeoff on runway 22 right in Newark. Our departure is over Colts Neck and White intersection. Cruising altitude is flight level 340. Landing fuel is approximately 6,500 pounds. That's about an hour and a half, and our alternate is Aguadilla, which is 10 minutes from San Juan. All checklists have been completed. We've just been cleared for takeoff, and we're just going to take one quick look around the cockpit, make sure we've gotten everything, also give you a good idea of what the inside of the 737 looks like. So the box has been loaded, checklists have been completed. We've just been cleared for takeoff. We've removed the yokes just so nobody gets confused. And it looks like we're ready to go. So with that said, we're going to go ahead, release our brakes, push our throttles up. Click on the auto throttles, and away we'll go.
$80 knots. V1, rotate. Positive rate.
Gear up.
$1,000. 400. $1,000.
We're going to go ahead and get the autopilot on, reduce my pilot task saturation. Start bringing our flaps up.
$1,000 to go.
All right, flaps are up. We'll call for an after takeoff checklist, and we'll get that out of the way. And then we're going to come back down to the box here briefly. Get the aircraft back onto LNAV.
Well, we are still in the climb and beginning to coast out. Let's open Ergo360 and see how the app is used in normal conditions. Flight plan information is automatically uploaded into Ergo360 in the ADS Oxygen ETP from a single source document. This should be accomplished on the ground using cellular or Wi-Fi, but can also be accomplished airborne if these services are available. This data automatically fills in all entries needed to drive both programs. Using the Ergo360 program is relatively simple. Pilot merely needs to select the app and then log into Ergo360. Confirm the recall number for the flight plan you're using, in our case today, X-Plane 1. Then confirm the data loaded from your flight plan is correct using a similar procedure to check oceanic waypoints, and then click Submit. The visual verification simply confirms that both fuel and oxygen range rings extend past the diversion airports. In this case, at Newark International Airport in San Juan. This confirms that the fuel calculated by the flight planning provider and the oxygen calculated by ADS are sufficient for this trip to comply with a critical fuel scenario. No more trying to look at tabulated data and trying to visualize if there's enough. It's already done for you. You can easily see how your situational awareness is improved by using this program. This is all that has to be done to pre-flight Ergo360. Confirm the tabulated input data and then visually confirm the output data. When I click Submit, the iPad will center around the actual iPad location, indicating we're ready to go flying. Remember, the range rings are based on low-level flight and will track now with the actual aircraft position. Let's look at the ADS Oxygen ETP. It can be accessed in two ways. First, during the login sequence when confirmation of the recall number window is open, or once the app is open like it is now under the Settings tab towards the bottom of the page. This is a transitional program built for users who would like to have a tabulated paper type record which records fuel and oxygen reserves from the equal time point to the diversion airport. This product relieves a pilot from having to sort through unfamiliar charts and graphs during an emergency situation and provides calculated fuel and oxygen reserves to be monitored in a similar fashion to that of a normal flight plan. Every flight plan and agency has a design they've developed to present data to the pilot to be used in the event of an emergency. Reviewing this data in a safe, non-stressful environment is one thing. Trying to find data in a non-standard format under a high cognitive workload can certainly be challenging even to the most experienced pilot. This program simply completes the planning for what the pilot is required to do during an actual emergency, and much like a normal flight plan, the pilot needs only to monitor the progress and make necessary adjustments in altitude to balance his fuel or oxygen. This program reduces pilot task saturation during a critical phase of flight. For this demonstration, we'll focus on the blue fuel and oxygen calculation worksheet and discuss the design layout and how it's constructed. Under the time column, the 15 minutes you see is merely a reminder of the length between calculated intervals. The first value is calculated time from the equal time point to the diversion airport. Each subsequent time below is reduced by 15 minutes and can also be viewed as a time to go before the arrival at the diversion airport. The next column in dark blue is what we refer to as a fuel ladder. It's split into two columns, planned and actual. The first row is the fuel remaining, and each subsequent row, the amount of fuel is reduced by 15 minutes of fuel consumption, calculated by your flight plan and agency. The next column over is a section to record the actual fuel remaining to evaluate fuel reserves, and in the same fashion that you would a normal flight plan. The next green data set is an oxygen ladder. Oxygen reserves can be determined on the flight deck using percentage of full, liters remaining, or PSI, pounds per square inch remaining. The pilot will use the metric that applies to the aircraft he or she is flying. The calculation is based on predicted oxygen supply remaining at the equal time point, and then predicted consumption based on 15-minute intervals provided by aeronautical data systems. The column labeled actual is to record the actual amount of oxygen remaining, just like we've done for the fuel. The other two fuel ladders shown are just for an engine inoperative or a high altitude emergency, and they're used in the same manner just described for the first fuel ladder. Once we get up to cruise altitude, we'll show you how to take the ship AIS data, that's the ship location data, enter it into the aircraft FMS so the aircraft automation can be used to fly an instrument approach to a water landing in the event a ditching becomes necessary. Now that we are at cruise altitude and have a little extra time, let's open Ergo360 and review the site picture. These are our diversion airports today, which just happen to be our departure and arrival airports, and in between is the aircraft icon. The green line emanating from the aircraft icon to the green circle is the oxygen range ring, and the blue line and circle represents the fuel distance range ring, both at a 10,000 foot altitude. The purple ship icons represent maritime vessels along your route of flight. Since no internet is available, the purple color indicates that the ship position is in a predicted mode. Touching the ship icon will open a data banner with pertinent information the pilot can use in the decision-making process. The first value you see from left to right is the time the vessel transmitted its last position. Next is the type of vessel, then the name of the vessel, the last ship position, the last ship direction and velocity, and the very last value is the distance from the aircraft to the selected ship. As you can see, this program is a great situational awareness tool and can provide lots of detailed information at the tap of an icon. So now that we understand the mechanics of the display, our next step will be to transfer ship position so it can be inserted into the aircraft navigation system, and I'll show you why this is an important procedure to commit to memory. It should be noted that each type aircraft will have a different way to insert the ship position into the aircraft navigation display. It'll be up to the user to find the most efficient method of transferring this information, and it should be practiced at least a few times on every flight to remain proficient with this procedure. After the data is transferred, we'll show you how to use a weather radar for actual ship position verification, and then show you how to construct an autopilot flown instrument approach to a water landing using the aircraft LNAV, VNAV functions. The first part of this exercise will be to select a ship along your route of flight at least 100 miles ahead of us, so we'll have time to methodically show you how to transfer this into the Boeing 737 FMS. Also remember, you may need this distance to descend, but each situation will be different and up to the captain to determine the best course of action. Remember, your avionics may have a faster method to accomplish this procedure, but that will be up for you to decide. It looks like a tanker called Speedway will be a good example since it's more than 100 miles ahead of us. We have some limited navigation functionality in the X-Plane Sim, and so this will be a little slower to load than the normal aircraft. Remember, whichever method you use to enter this data, be certain it does not compromise the active en route navigation you normally use, since you could easily steer off course. This process should be a procedure you can use to view ships passively, since this is what you'll be doing all of the time except during an emergency. So right now, we've identified that we're going to use a tanker called Speedway, and we're going to come down here to our FMS, and we're going to go to the Boeing nav database, and we're going to enter this as a waypoint. And we are going to identify this as ship 01. You can pick anything that you like. If you want to give an abbreviation for the name of the ship, that's okay as well. And next we're going to go ahead and enter the longitude and latitude of Speedway. So it's north 3 2 42.8, and we'll enter that. And longitude is going to be 068 46.6. We'll go ahead and enter that, and now we have a waypoint. Next, and this is for the 737 FMS, we're going to put this right now into the fixed page, which I believe most FMSs have. And there you go. There's our ship, Speedway, present position, and we're en route to Bexham at this point. Let's say we have an emergency, okay? And normally, again, this is the limited functionality with the X-plane. Normally, we'd be able to slew this waypoint down, but we're going to go to legs page, and in the scratch pad, we're going to type in ship 1, which is the Speedway. Insert it into our legs page. Pick the correct latitude and longitude. And there we go. And simply to go there, we would just click on our execute page. And then from here, we would be able to set up an LNAV, VNAV approach using the aircraft automation to land the aircraft. Once you've established this procedure, this should become instinctive, since you'll want to be able to transfer this position quickly and accurately during such an event. Once the ship is available as a waypoint in your navigation database, as you've seen, we can simply insert it into the legs page, fly directly to the ship, whether it's at night or low cloud cover, low visibility, and you're unable to see the ship. Again, this significantly expands the ditching envelope without question. Next, I'd like to show you a procedure developed by Aeronautical Data Systems which resulted as an unintended consequence during our research. Our verification of ship location using only a visual sighting was quite restrictive and extremely slow. We were limited to only day VFR conditions where we could see a ship. It should be noted all ditching procedures available are for day VFR only as well. So you'll see using this technology will significantly expand the safety envelope for all overwater flights, since you no longer need to see the ship you're ditching by. We discovered using the onboard weather radar in such a manner where we could easily paint ships on the ocean with incredible accuracy and detail. Since all of our test flights were used without internet service, this allowed us to physically verify the accuracy of the AIS data, the ship location data we were downloading. The next few slides are pictures of ship location painted by the weather radar during our location validation testing we conducted to verify our AIS vendor was providing correct, up-to-date data. On the first slide, we've set the radar tilt almost full down. Do this while adjusting the gain will produce a green arc as shown above. Ahead of this arc, you'll see a typical FMS generated waypoint representing ship position. This next slide is a ship passing through this radar arc showing actual real-time ship position. This slide is typically what the FMS and the radar will look like when using Ergo360 to provide this data. Here you can see the FMS ship location and the actual ship position are almost co-located. This is another screenshot with several ships in the area passing through the arc that we've created. And finally, this is what a typical FMS will look like setting up for an instrument approach to a water landing, attempting to get as close as possible. Without this technology, none of this is available. Ergo360 provides this data at the touch of an iPad icon. We have a little extra time right now, so we're going to go ahead and put another waypoint in just for practice. As you can see on our FMS, We are just abeam speedway right now, and you can see down here on our iPad, we can also confirm that. So we're going to go ahead and pick another ship in front of us here. Let's pick this ship here. This is the Caroline Selmer, and we're going to enter this into our database. So if we remember, we're going to come back, find our nav data page where we can insert a waypoint. We're going to call this, if you can guess, ship 2. We're going to enter our latitude and longitude. It's 30052. North. And then west, we're going to be 067032. And that's it. We just put this into our database, hit the execute button, and now ship 2 is logged in our waypoint database. We can come down here to our fix page and enter ship 2. And it looks like it may be out of our range, so let's expand our map a little bit. And there we are, about 160 miles right in front of us. It's going to be ship number 2. And it's just as simple as that. But what a truly marvelous situational awareness tool to be able to see these ships, at your discretion. Whenever you want to put them onto your database or put them onto your navigation program, it's a simple thing to do. Now it looks like we've burned the fuel out of our center tanks, so we'll shut them off. Also, Tasney is our halfway point. Anything past Tasney, we're going to continue marching forward on to San Juan. And that should do it for now. We'll be back with you with an update very shortly. Thank you. The last video clip I want to show is how the Ergo SOS tab is intended to be used in an emergency. The most difficult task to use in the SOS feature will be to make the decision to ditch the aircraft. Activating the Ergo SOS system is like sounding an overwater all-call fire alarm, since it can transmit over 200 nautical miles, and all deep water vessels will be notified first by an alarm that activates over their radio and must be silenced manually. Also, sent at the same time is a text-type distress message with your aircraft data also received and displayed on all maritime radios. This is sent over a discrete data frequency required by all deepwater ships to monitor. Once this message is sent over the data frequency, the handheld radio you are using will automatically change frequency to the maritime voice distress frequency. The next transmission will require the pilot to select a ship before the message can be sent. Once the ship is selected, the pilot need only to press a confirmation button on the iPad, and no other pilot input is required from that point forward. Assuming the pilot knows which ship to ditch by and is trained in using the app, the entire process can take less than 10 seconds to execute. Using iPad technology, aircraft data such as position, altitude, true airspeed, time to water landing, number of souls on board, the name of the ship you'll be ditching near, the current UTC time, will continue to transmit over the voice frequency every 2.5 minutes with updated information. It's all automatic, in real time, and to real people who can help you immediately. Using the Ergo SOS Maritime interface allows automation to reduce pilot task saturation in time of rescue without changing or compromising other training procedures used in the past. Hands down, it's the one piece of overwater technology you want to have with you. One last thing I'd like to point out is that training or practicing to send an actual SOS message can be practiced on every flight as long as the cable needed to connect the iPad to the radio is not plugged in. This will give flight crews confidence in using the SOS function by building muscle memory and visual expectations as to how the app is supposed to operate normally. Okay, let's walk through this process now in slow motion, and then we'll use the app in real time. This procedure should begin after the decision to ditch is confirmed by the pilots, an emergency with ATC has been declared, and the audio cable from the iPad to the handheld radio has been connected. First, the pilot will touch the SOS button along the bottom right menu. This will bring up a very important confirmation message to preclude the flight crew from sending an inadvertent emergency message. Assuming the pilots have declared an emergency, this prompt can quickly be submitted by pressing OK. Several things will happen here. First, you will hear a data message being sent. It sounds similar to sending a fax message. You'll only hear this audio if the cable from the iPad to the radio is not plugged in. If a cable is connected, no sound will be heard from the iPad. Instead, you'll see a transmission symbol appear in the white lower left banner portion of the Ergo app. This data message is brief, and as such, this transmission icon will also appear brief as well. Almost at the same time the data message is being sent, the iPad screen will zoom into a 200 nautical mile scale and display all ships and airports in that area. This function is to declutter the iPad screen and help the pilot to determine assets closest to the aircraft. Should no ships or airports appear inside the 200 nautical mile radius, the pilot can open the Map Overlay tab and refresh the Vessel tab to display ships outside of the 200 nautical mile scale. The pilot must choose a ship in order to activate the voice distress message. To select the ship, the pilot will have to touch on the ship icon, which will open a data banner with ship information. If the ship is unacceptable, then choose the cancel option. The pilot can select another ship. Once the pilot selects the ship he intends to ditch by, then pressing the OK button will activate the voice distress message that will get sent automatically over the maritime frequency channel, channel 16. Remember, if this is a real event and the audio cable is plugged into the iPad port, no audio will be heard, but the pilot will see the transmission icon again in the lower left side of the white app banner. During a real emergency event, the pilot will see the transmission banner appear every 2.5 minutes as the iPad updates the voice distress message. The pilot at any time can use the handheld radio to speak directly with a ship by unplugging the audio cable and pressing the handheld radio transmit button. There will be no doubt in future improvements as the industry evolves using this new technology. Now, let me demonstrate using the app in real time.
Mayday, mayday, mayday. This is aircraft November 800 Whiskey. We are abandoning aircraft in the vicinity of Bandura. Repeat. We are abandoning aircraft in the vicinity of Bandura. Position 28 degrees 2 minutes north. 70 degrees 51 minutes west. At 1939 UTC requesting passenger and crew rescue. Repeat. Requesting passenger and crew rescue. Persons on board 12. Aircraft speed 0 knots. Aircraft altitude. Descending through 419 feet 1 minutes to water landing. Over.
And that's how easy it is to use the Ergo program.